welcome to this next episode of Graphwise demo applications. Our demo applications showcase the business value of graph-based applications. You know, Graphwise has been a result of a merger between OntoText and Semantic Web Company, two companies which have helped their customers for over 20 years to benefit from knowledge graphs and related technologies. So today we will take a look at an application called the HR Recommender. It's a great example displaying how recommendation services can help businesses to achieve their goals more efficiently. HR Recommender showcases let's say a scenario in which companies try to staff their projects in a more efficient way, help employees to identify contact persons, having a specific skill set, for instance. So HR Recommender is one of those examples where you can quickly grasp the idea how semantic knowledge models can help drive the results in a very precise way. And let me start with an example. So let's say this fictitious company has a couple of employees and you would like to log in as one of those. Let's say I'm Christian Miller. I'm a taxonomist. What you see instantly here is a set of colleagues, a set of open positions, and a set of projects in which Christian or myself could fit in, which means the skills and competencies attached to Christian correlate with the needs to fulfill the challenges in this given project or in this particular roles. Or it also means that Christian, for instance, has a lot in common, has commonalities with Monica, which means, okay, let's meet. Maybe they work cross-departmental or in different locations, so in larger companies, or just a merger has happened probably. So they could meet and identify interesting topics to talk about. So this is what this first visualization of this network around Christian could mean. And as a next step, Christian now would like to understand which are the projects he could fit in very well. So he clicks on projects, gets already a list of projects he could work for. So for instance, in that case, Shekel-based data lifecycle management. Why is that? Because the description of this project has been analyzed by our text mining module Pool Party Extractor. And the Pool Party Extractor has then been used to identify relevant topics, which are then again mapped against Christian's skills profile, which is based on a skills taxonomy, which, by the way, we started off from a heavily used skills and competency related thesaurus called the ESCO thesaurus. And this ESCO thesaurus has been expanded by using Pool Party's corpus analysis in a couple of iterations. So we now have a specific skills taxonomy in place, which is good for analyzing IT-related jobs and profiles. So in other words, Christian's profile, which is shown here, so those are the elements where Christian has skills for, is related to those, let's say, topical topics which got extracted by identifying relevant skills from the descriptions of the project. So here in the middle, like the keywords, you see For instance, linked data is a perfect match. So it's mentioned in this project description, and at the same time also Christian has skills around linked data. In gray down here, you see, for instance, here natural language processing has been mentioned inside this project description, but it's not directly, like explicitly mentioned in Christian's skills profile, but indirectly. And this is exactly where semantic knowledge models play a very important role. So they can really infer from skills like, for instance, linguistics or information science, that Christian obviously has good skills also to fulfill the needs of this project, which is in strong need of natural language processing. So this kind of inference mechanisms play an important role in many, many business related challenges. So as you can see, the extraction of Graphwise technologies goes beyond simple keyword extraction. It really extracts the concepts. And by that, we can look up in the knowledge model, okay, what does it mean? What is the context around a given concept? And so therefore, you can infer also that this project is relevant for Christian, and in simple NLP technology, you would not have identified that. So that wouldn't have been possible because there are no overlaps in an explicit way. So what else can you do here? So very nice feature is, for instance, you can say, well, I'm no longer interested in linked data that much, so I would like to change over to do more work in areas, let's say like taxonomy management systems and metadata management and things like that. And by that, the system understands a kind of a weighted profile and can bubble up projects for Christian he would probably like to work in the near future to develop his career path further. So this is how the HR recommender helps link people to projects. Same principles are valid for open positions. So as you can imagine, as an HR manager, you, for instance, could far quicker find good matches between applications and open positions, and also to strengthen the social networks inside the company. The same mechanism can be applied to identify people who can work in different on different topics all together. So, like for instance, Christian would like to talk to Evert or Monica or Tristan to strengthen his knowledge profile around the given topics. So how does it work? In general, it is using the Pool Party Semantic Suite to analyze all kind of texts around open positions and applications and people's profiles. And here we calculate a so-called footprint. So the semantic footprint of Christian is based on his CV. And this is done automatically. So there's no need to do any manual tagging anymore. So it really scales out to thousands of people and hundreds of thousands of project descriptions, etc. So this demonstrator shows principles around concept tagging. It also shows how the recommender service can be used to drive applications. Recommender services are one of those frequently used, let's say, technologies to make applications smarter. It's also used, as we can see in another episode later on, together with LLMs. And so it really helps to retrieve relevant pieces of content from different repositories in a highly precise manner. And recommender services are frequently, I would say, misunderstood even. It's frequently used for more of the same recommendations. So recommender services are frequently just producing more of the same. So as you can imagine, you couldn't do that, for instance, with the HR recommender that easily. You need to infer from CVs what's really relevant to the given person. And here it's even more obvious that it's not only more of the same what a recommender service should do, it's really how do things fit together. And this is the wine and cheese recommender demo, which is also publicly available. So it's a couple of wine and cheese products here in this shop system, in this fictitious shop system. And so the matchmaking between the wine and its different characteristics and cheese has been modeled in a corresponding knowledge model, again using the pool party Desaro server has been used to model that. And you can retrieve different products by that. That's one of the simple but very efficient elements here. So you can say, I just want to have maybe mature cheese. And by that, you see a couple of the products which are still available. And now I take maybe one of those and get in return. So here's a short description, the cheese descriptors. And here are similar cheese brands. So this is, again, more of the same, so to speak, similarity-based recommendation. But here you see really this is going beyond similarity. So which wine characteristics and products by that go well together with this Dutch cheese called Stolwijke matured farmhouse cheese. So the first recommendation would be the this wine here with those descriptors, and these descriptors have been put into the model and have been made available as a kind of a mapping trigger. It says, okay, for instance, dry wine goes well together with mature cheese, etc., etc. And this actually is a great example how Graph can help solve a combinatoric problem. Because in reality, if you have 1,000 wine products and 1,000 cheese products, there are millions of possible combinations, and you would really get lost if you were to model those one by one. And with a knowledge model, which is essentially a graph, you do that on an ontological level, on an abstract level, and by that the system can extract or recommend the right products quite easily, and in a very efficient way. You can expand on the model, and even better, it can be maintained and used by the subject matter experts. So those people who really know which wine, which cheese goes well together can look at the model and can do the modeling by themselves. So there's no need to involve any kind of programmers. There's no code really in play in place. It's really just a model, and then a corresponding Sparkle query at the end of the day, which is the only let's say critical pathway in this application where you need a deep semantic web knowledge. So this is another example of a recommender service. Recommender services are used all over the places. Of course, we all know it from e-commerce, but as showed before, it can be used in HR-related processes, in product innovation processes, in all kind of retrieval related activities, like as we will see later, also in Graphwise applications. So they're all over, and Graphwise has its own module for that, own APIs. We can configure such recommendation services quite in an efficient way, and the quality of the output is always driven by the model under the hood, and the model itself can be looked at, can be used by subject matter experts. Really, that's one of the strengths of our platform, that it involves the knowledge of the people who really understand the domain very well. Yeah, so that's it for now. That's one of the episodes we have here in this series of Graphwise demo applications. I hope that's helpful for you to better understand how our clients can benefit from our technologies. Thank you and have a great day.